Thanks for tuning in. This video is one I've been working on for a while, so I am finally going to show you how I will have internet access on my bus as I get the conversion done. So let me start this video off by saying a couple of disclaimers, I guess. The first is none of these products are sponsored. I'm not getting paid for saying any of this. And the second is I do enterprise IT networking for a living. So my skill set when it comes to information technology and networking and all of this gear is a little higher than the average consumer. Most of this stuff is not consumer grade, meaning you can't just go and buy this stuff at your local Best Buy or Walmart. This stuff is all enterprise grade. And that being said, it's not exactly DIY friendly, but I guess you could argue that converting a school bus into a motorhome isn't exactly DIY friendly either, and people figure out how to do it. So if one were so inclined, they could figure out how to do all this stuff, but it would not be easy. I have the advantage of I work on all this stuff for a living. I'll give you a high-level overview of the gear I have and what it will do. So my goal is, because when I'm on the road, I will still need to work, and the majority of the work I do can be done from anywhere where I have a computer and internet access. Most of my conference calls with clients takes place over either Zoom or Microsoft Teams, mostly Microsoft Teams these days. And the work I do on my clients' networks is all done over remote sessions. So as long as I can VPN in or get to a remote desktop at the client somewhere, I can do my job. So with that, I can work from anywhere as long as I have reliable internet. And being the fact that I'm going to be traveling all over the country with my bus, different internet types may or may not be available where I go. So I've got a lot of different ways I can connect to the internet with this setup. And so the overall goal is to build a setup I can connect to multiple different ways, and depending on how I've connected, control that. So a lot of people, you'll see videos, they get like a PepLink device and, they've got maybe a Starlink or a Wi-Fi connection or two, or they just use their hotspots on their phones, and that's fine for most users. Like I said, this is a very advanced thing I'm trying to do here. Way more complicated than it needs to be, but it's what I do for a living, and my whole bus is complicated, so why not continue the theme? So I'm going to go over kind of a high level first, and then I'll actually get into the configuration of this gear. So for people who don't really care, they can cut out when I start showing screenshots. But the high level overview, my primary source of internet access is going to be Starlink, and that's the little device you see in the upper right hand corner of the video there. Starlink, there's a million videos and there are a million articles on the internet about it. I'm not going to go into a lot of detail, but suffice it to say I do have the RV plan, so it'll work anywhere that isn't overly congested, and I can pause it when it's not in use. So I have it active right now. I've been using it for a couple different things on some projects here, but it'll go into pause mode very shortly, and then I won't pay for it again until I need it. Secondary source of connectivity is wireless as a WAN, or Wi-Fi as a WAN, otherwise known as a wireless uplink. So if I'm parked somewhere where I can pick up a public Wi-Fi signal, like a campground or like a Starbucks or a McDonald's, I can connect this to an uplink Wi-Fi signal and use that. Now you may ask, why don't I just connect my laptop right to that signal directly instead of going through all of this stuff? There's going to be a lot of devices on my network, and I don't want to have to change them all every single time. I want everything to always connect to the same stuff, and then whatever I uplink to get internet access will be what it is. The bus will have, my laptop, my phone, a variety of tablets, probably a sound system. There's a Plex server I'll get into in a minute. And so I want to have a fairly consistent and stable internal network. And then the last two options I have for now, I have two different cellular uplinks. The first one right now is on the T-Mobile network via Google Fi, which is what I use for my phone. And the second one is via an AT&T prepaid plan. I can always add more cellular connections onto that, such as Verizon if I wanted to down the road. I don't have those for right now because there's no point in paying for it. I don't need it. The Google Fi and AT&T is good enough for what I'm doing for right now. So at this point, you may be asking, why am I setting up all this stuff now? My bus, is not even fully gutted yet, and there's a couple of reasons behind that. One, I've been acquiring this gear over the last 8 or 9 months, and so now that I have all the parts and pieces I need, it was a good time to put it all together. But second, my shop is starting to get enough inventory of tools and other gear there that I need to get some security cameras up and going again. And so since I don't really have the ability to mount Starlink out there the way I did at my old shop, that's why I bought that AT&T prepaid plan. It's $25 a month for 20 gigs of data. It's prepaid for a year. And so the security cameras that I have will work just fine over the AT&T Wi-Fi connection. AT&T cellular connection, and that way I can keep an eye on what's going on in my shop. That is the setup, and I'll start to get into some of the specific components here now and how this all works. So starting on the left here is the wireless access point. This is a Fortinet AP model 224D as in Delta, and this is what every device in my network will connect to. So my laptop, my phones, my tablets, etc. This is what puts out the Wi-Fi signal that I connect up to. There'll be two SSIDs or two wireless networks running off that. The first one's the primary one I use. The second one is a guest network if I have, want to allow people access into my internet. And there will probably be a third Wi-Fi network that I will use for my work laptop that I'll deploy later. The second device here has the Hughes logo on this. This is the Fortinet FortiGate firewall. This is a model 61E as in Echo. This is a Hughes rebranded one. Hughes and Fortinet had a partnership where Hughes used these boxes for their customers for a while. Like I said, all this stuff is used off eBay, but functionally it's the same thing. It just has the blue Hughes logo on it instead of the red Fortinet, but you can kind of see on the front where it says powered by Fortinet. Below that is my primary switch. This is a TP-Link switch. I got this off of Amazon. I wanted to go with a Fortinet switch, integrates better into the whole system, but in order to get one that was full gigabit and PoE plus, those right now on eBay were running very, very expensive, more than I wanted to pay, and this was significantly cheaper, so it gets the job done. So this switch has 16 ports available on it. The first 8 are full PoE plus. PoE is power over Ethernet. It allows you to run power to things through the network without having to run additional power cables. So almost everything on this desk that will get its power via Ethernet. The access points, the security cameras, as well as the FortiExtenders here for the cellular, and I'll get to those in a minute. So this FortiGate is actually what's called a FortiWifi model, which means it has a built-in wireless. And you may ask yourself, well, why would you have a separate access point to the left if this thing has built-in wireless? The advantage of the built-in wireless is you can convert this to uplink mode instead of downlink mode. So with these two external antennas up here, that is how I would connect to McDonald's Wi-Fi or campground Wi-Fi. And these antennas are external. They're not permanently mounted. It's just a little magnet on them, and they've got about an 8-foot cord. So when I go to install this in my bus, those antennas will actually sit up on the roof of the bus to pick up the signal better. Continuing to go left to right, this is just a kilowatt. This is kind of giving me an idea of how much power this setup is drawing. Right now, with everything turned on except for the Starlink, it's pulling 71 watts. So that gives me an idea of my power usage. Up next are the two Fortinet extenders. These are called FortiExtenders. These are model 40D. This model is 4G capable. It is not 5G capable. There are newer models that are 5G capable, but they are significantly more expensive. Again, this stuff is all used off eBay. The 5G models are considered current or production. It's what businesses actually use, so they are not really selling a lot of that stuff secondhand. This stuff is considered previous generation and is readily available. So I've been picking these up off eBay. So there's two of them here. The first one is connected to AT&T. The second one is connected to Google Fi, which runs off the T-Mobile network, and I'll talk a little bit about those carrier plans later. Normally these come with just these little paddle style antennas. You notice there's one antenna on there that's for the GPS signal, but I will take you around the side of my desk, pardon my messy office, and I have these two external LTE antennas. Right now they're just sitting in the window to pick up better signal. Kind of gives you an idea of what they look like. Okay, just a real quick interruption. I'm editing this video right now and realized I didn't clarify this. And no, this will not be for an advertisement. These FortiExtenders do have two different SIM card slots, which means you can put two SIMs in here and connect these to two different wireless carriers. But it only has one radio in it. So that means only one SIM card can be active at a time. So if I were to put both Google Fi and AT&T into this at the same time, I would have to manually go into the system and tell it to connect the other. I couldn't use automation to tell it to flip back and forth between the two carriers without manual intervention. So that's why there are two separate devices here instead of putting both SIM cards in one device. So with those two external antennas, again, those would be mounted on the roof of the bus. It allows me to pick up a stronger cellular signal into the system. Buses with a giant metal roof kind of act like a Faraday cage, and they tend to block signals. So I want all of my external connectivity antennas to be up on the roof, and then everything I connect to inside the bus locally. So this access point on the far left would be inside the bus. Those two black antennas and the two cellular antennas in the window would be on top of the bus. Continuing to move over to the right, this is a Unifi cloud key along with two cameras. These will probably not end up in the bus. I'm going to go with a different camera system, I think, for the bus. These were the cameras I had out at the old workshop, so I set them up here. And when I move all this gear down to my workshop later tonight and get it set up, these are the cameras that'll run in the shop for now, but these probably won't make their way onto the bus. Below that is just a very cheap little gigabit PoE switch. You may ask yourself why I used a separate switch instead of plugging that stuff into here. Two reasons. One, this switch is what's called a smart switch. It's capable of doing VLANing, and the little one over here is not. And second, only 8 ports on this are enabled for PoE, and I may have other devices on the network that will use PoE, and I didn't want to burn them up all with the cameras. And like I said, these cameras aren't going to make their way into the bus anyway. I have no idea what that new camera system is going to look like, so for now I just set up this little switch here. And then over here to the right is the Starlink. I talked about that a little bit earlier. The actual on my deck, and you can see the cord snaking out of my home office and down the stairs and out onto my deck. And below that is the power brick. So this, I like it because it's got the little blue LED lights, but this allows me to turn individual components on and off at a given time. So I've got right now little sticky notes that are indicating what is plugged into what, so I can turn things on and off as I want. Eventually I will get nicer, fancier labels to actually put on the thing once I know what's in the final setup. And last, this is a little Lenovo micro PC. It's just running Windows 10, but this thing is doing a variety of things. It has an upgraded 1 terabyte SSD drive in this. So the primary function of this is running Plex media server. What I have done is I have taken my entire DVD movie collection and digitized them into files. And so I can stream all of my movies locally on the bus without having to use internet data. And I don't have to drag around a bunch of DVDs with me or hook up a DVD player. Every DVD I own is just a digital file right on this box. This box will also always be running inside the bus, so I can connect to it remotely. I can look at cameras if I need to, although the cameras would uplink. I should be able to get to them from my phone over the internet, but it would give me an avenue into there. I can run other services on here as I need to. This thing's pretty small, doesn't take up a lot of space, doesn't draw a lot of power, so it's a perfect little box for that. So that is the setup as a whole. We'll start to get into some of the configurations. Like I said, if you want to do this stuff, it's pretty advanced. I'm not going to get into the networking specifics. Like I said, I do networking for a living and actually teach networking at the community college level. And even some of my students who are like seeking degrees in information technology think that listening to me talk about layer 2 switching or layer 3 routing or VLANs or firewalling, even some of my students say I'm boring and don't want to listen to my lecture. So I'm not going to get into some of those specifics, but I will now dive into some of the configurations on some of this stuff. And so if you're only interested in, at a high level, how I make this work, you can probably tune out now. If you want to see some of the specifics, then hang on and I'll show you some of the configs. Okay, so first here, this is just my Plex media server. These are several of the movies that I have loaded. So when I have the TV in the bus, it'll probably be a Roku device that will connect to Plex. That's what I use here at the house. And so right from my TV, I can watch any of these movies that I have. If I buy a new movie on DVD or Blu-ray, I can use my laptop and the built-in DVD player in that to convert it to a digital file and load it into the system. So that's how I run the Plex. Moving forward, this is the Unifi system. This shows the 5 cameras I have for right now. And if I click into here, this looks like any other security camera system. Right now, the cameras are just sitting on the edge of the desk pointing at various spots in my office, but these will be out at the shop eventually. Like I said, this system will probably not make its way into the bus eventually. And now we get to the meat and potatoes of the system. This is the FortiGate system, and the primary job of this is to control the traffic, where it's coming from and where it's going to. Up top are the 2 FortiExtenders. These are my Wi-Fi connections. So you can see I've got one connected to AT&T and one connected to GFI, which stands for Google Fi. Those are my cellular uplinks. Down here in the physical interfaces, there's one interface dedicated to security that's going over to that little switch that all the security cameras are plugged into. It's plugged into port 3 on this firewall. The Starlink plugs into the port called WAN 1. You can see that's currently red and in a down state because I have that shut off. The switch uplink, if I expand this out, goes down to that main switch, and these are the different VLANs that exist on that switch. So there's a VLAN for the access point itself for management. There's a VLAN for the FortiExtenders. So the FortiExtenders live in their own VLAN, and then they create the cellular connection for the internet up here. Right here is the LAN connection. This is my primary internal network where my laptop, tablets, phone, any other multimedia video systems, etc. will live. Down here is the Plex box that lives in its own dedicated zone. And then I've got this one here for work wired. When I take my work laptop with me, I want that in a dedicated zone. It will have access to different things that my internal stuff may not, and vice versa. Plus, my company, like most others, has plenty of methods on the laptop to monitor what's going on. And, they don't trust me with access to the accounting system, even though I would never do anything nefarious. I don't trust them with access to my home network, even though they would never do anything nefarious. In the IT world, we call that theory of least privilege, and that's something I extend to my home network as well. So any of my work gear is always separated from all of my personal stuff. Down here, this is a dedicated port for managing that switch. Because it's a cheap little switch I got off Amazon, it's got some funky things with management in regards to VLANing, so it has its own dedicated port. I didn't want to do this, but I was forced into it. Down here, and yes, I'm skipping over the SD-WAN stuff. I'll come back to that in a second. Down here is the Wi-Fi client. This is the Wi-Fi as a WAN, so this would be any uplinks to public Wi-Fi, McDonald's, Starbucks, campground, etc. And down here are the wireless networks. The first one is called Bang the Drum. That's a Todd Rundgren reference from his song, I Don't Want to Work, I Just Want to Bang on the Drum All Day. This will be the Wi-Fi network for my work laptop if I'm moving about the bus and not at my desk wired in. This gets bridged to the work wired network up above. Here's the main TSLABUS Wi-Fi network. That's basically the LAN connection for any wireless devices. And then last is TSLABUS guest Wi-Fi for guests that I want to allow onto the network. I should interject here quickly and say when I talk about guest access onto the network, that is a dedicated zone and they would not actually have access to anything on my internal network. So anybody connecting to my guest would not have access to my laptop or my work laptop or even the Plex media server. That would be just to allow them internet access, and that would be controlled by a firewall policy here. So I have 3 different SD-WAN zones. This top one is just a virtual WAN link. That's a default configuration. It doesn't get used for anything. This one here is called SD-WAN Core. These are my primary and preferred methods of internet connectivity. You can see the first one with the cost of 1, priority of 1. This is Starlink. So even though Starlink does cost me, there is a data cap on it, but it's ridiculously high, so I'm not overly concerned about that. And this is the best option I have, so when available, I want all of the traffic to prefer the Starlink connection. If that's not available, the second best option is Wi-Fi as a WAN. That's the Starbucks type of public Wi-Fi. You can see I have this one set as a cost of 5 and a priority of 2. Again, the cost is kind of irrelevant. That's used for factoring in which connection is preferred. But most of those public Wi-Fi signals aren't the strongest, aren't the best bandwidth. So I prefer to use Starlink if available. But if Starlink's not available and I do have a wireless uplink, I want to use that over a cellular connection. And I can manually go in here and turn connections on or off as I see fit if I want to send traffic in a certain direction at a given time. But for the most part, I want the defaults to be my preferred strategy. So most of the time, I figure if I'm going to be parked in an extended period of time, I'm going to have the Starlink out and I'm going to be using that unless I'm in a highly congested area and I can't get Starlink to come up. If I'm on the road and traveling and I stop somewhere for an hour or overnight or something like that real quick, and there's a Wi-Fi uplink available from a parking lot, I would use that. And then below that are my SD-WAN cellular connections, and here is the AT&T and Google Fi. I have these costs and the priorities are set equally. The costs are set right now, so the AT&T costs a little bit lower. I prefer to use that connection. The AT&T is prepaid. I've already paid for that 20 gigs of data, whether I use it or not, so I prefer to use that for the things going on with the cameras. My Google Fi right now I'm paying for as you go, so I pay $10 per gig of data I use. I will be switching that over to their Unlimited Plus plan, which is unlimited data, which when they say unlimited really means 50 gigs of data. So eventually these priorities will switch and I'll prefer to use the Google Fi, which is T-Mobile network, when available over the AT&T because there's more data available from that one. But for right now, I don't have that, so the AT&T is priority. And below that, this is SD-WAN, IPsec, and L. NL is my home, and this basically builds a VPN tunnel back to my home for certain things I have to do out of home. I won't get into a whole lot of the complicated stuff behind having a VPN tunnel back to my house, but there are certain things that run here that I would need access to. Looking in here, so anytime I park somewhere, I will have to come into this and tell it to uplink to the local Wi-Fi. Right now, this is connected to random public Wi-Fi. When I'm out on the road, this is where I would connect to McDonald's or Starbucks or random campgrounds. Looking at the APs, this is just that AP that's connected here and the networks that are being broadcast off this. Because it's all integrated into the firewall, it's all managed from here. I can control the firmware from here, check on its status, things like that. These are the two FortiExtenders. And this is where it gets cool, is I can set the data plan here, but here I can specify my monthly cost, what the data allowance is, and when the date resets. So the FortiGate will actually keep track of how much data has gone through this, and when I have maxed out one connection or the other, it will take it offline and stop using it. So when I exceed my 20 gigabytes a month from AT&T, it will stop using this and it'll switch over and start sending data out the Google Fi. Again, this is assuming that both the wireless as a WAN or Starlink is unavailable and traffic is going out the cellular to begin with, but that keeps me from incurring overages on the cellular connection. Up next are my traffic shaping policies, and this is the reason that those SD-WAN zones are broken out separately for core versus cellular. So within here, I'm telling the firewall that certain types of traffic need to be bandwidth limited when on cellular. So the first one here is streaming. So anything that's going to these streaming destinations, these include Hulu, Netflix, YouTube, Amazon Video, anything that's a video-based source that's high bandwidth, I want to apply a shaper to it and restrict this to 2 megabits per second. The idea is that, anytime you're streaming a movie, and it will try to stream in 4K, which uses a lot of data. By telling this to restrict the bandwidth to 2 megabits per second, that is a low enough amount of bandwidth that those devices will automatically rate themselves or throttle themselves down from 4K to 1080p or to 720. From what I was reading, most video streams at 720 run at about 1.5 meg. So, and 1080p runs between 3 and 4 megabits per second. So by setting this limit to 2 megabits per second when accessing a streaming service, that will cause it to auto throttle down to 720p, a little less quality, but it also will use significantly less data. And again, this only applies when on cellular. So you can see that traffic destined towards these streaming groups or these specific Hulu and Netflix addresses here will apply this 2 meg shaper when going out AT&T, Google Fi, that's connected to the SD-WAN cellular. I also have a policy in here. I have not tested this yet. I don't know how well it's going to work, but there is a policy set for Microsoft Teams traffic, again, when on cellular, to restrict to 1.5 megabits per second. Microsoft Teams is a little bit unique in that we use it for instant messaging and collaboration and sharing of files. We also use it for audio calls and video calls. So I can't, and Microsoft does not really separate out those different streams. They treat it all as one. So I don't know how well this shaper of 1.5 megabit per second is going to work. The idea is I know that Teams will disable video if the bandwidth gets low enough. So what I want it to do is when I'm connected to cellular, I still need to be able to instant message and access collaboration documents and things like that. But I want it to kill video traffic on video calls. Every time I connect to an internal meeting, the vast majority of my coworkers share video. It's kind of our company, it's not really policy, but it's kind of our company culture norm to share video when you can. So I want to make sure that when I'm on cellular, I restrict that video as much as possible in order to save data. Okay, now we get to the fun stuff. This is the firewall policy, and this is where it all kind of starts to come together. So I have several different policies here, and I'll kind of go through them one by one. But the first one is for traffic, and I've got this sorted going into the SD-WAN cellular zone. So in addition to those throttling policies, there's also some traffic I want to outright block. So what this is saying is that, generic ping and DNS and network required traffic, that's allowed to go out cellular. But anything that is trying to go to updates should be denied and blocked. So I'm blocking antivirus updates, I'm blocking Microsoft Windows updates. There's another policy here called this update groups that include things like Google Play. I really don't need my computers or phones to download updates when I'm on cellular. They can wait a couple of days till I'm on a different, more preferred network. So if I'm on Starlink or a wireless network, then they can download updates. There's no point in burning cellular data for that kind of stuff. Here is another policy just allowing video. The throttling policy is in a separate area. I still have a dedicated policy for this, but it's really not doing anything other than just saying this traffic is allowed. Here's a policy for the Plex server, that little micro PC I have over there going out. Again, it's allowed on cellular to access general network resources, DNS, NTP, that kind of stuff. Here, that box runs Avast antivirus, and so those updates are blocked, as well as Microsoft Update. Same thing here with the security zone. Because it's a Unifi, I am blocking known update sources. I don't need those cameras to update their firmware when I'm running on cellular. So I know that Unifi uses this Fastly Content Delivery Network, or CDN, and so I've specified a couple of download addresses I know they use, as well as this updating service. And then I allow access to streaming. Because it records locally to that cloud key box I have here, these cameras are not streaming across the internet 24/7. They only stream across the internet if I open the app on my phone and look at them. But those cameras do occasionally check in with the cloud service for that remote access, so that traffic is allowed. The next policy here is for guest Wi-Fi. When I'm running on cellular, all guest Wi-Fi traffic is blocked. I'm sorry, but my visitors, if they don't get to burn my cellular data, they can turn off Wi-Fi on their phone. And then similar here, there's another policy for my work zone. For my work laptop, when I'm running on cellular, certain things get blocked. So there's policy here for Teams that is allowed, that is throttled elsewhere. There's policy here permitting access to Office 365 and Azure, some things I use for work that are necessary. My company uses TeamViewer for remote management of the laptop. I don't need anybody from corporate remoting into my laptop and burning cellular data, so I block access to TeamViewer. We use Sophos at work for antivirus, so those updates are blocked, as well as Microsoft updates. That's not to say that my work laptop will never get these updates. It just means that when I'm on the road with my bus and connected to cellular, as far as they're concerned, it's offline. When I connect to Wi-Fi, or I'm back home or whatever, or if I'm on Starlink, then they can download all the updates they want to my work laptop. They just don't get to do it when I'm on cellular. On the flip side of it, any traffic going into SD-WAN core, which again, this is Starlink wireless uplink, this is pretty much all allowed traffic. There's really not much restrictions going on. I've got nearly unlimited bandwidth on those and unlimited data, so they're designed just to flow out and let it go. So yeah, that is the overall setup and configuration. If you have any questions, drop them in the comments. Hope you found this somewhat educational and not overly boring, and you got something out of it. Look forward to seeing you in the next video. Hopefully we'll be down at the shop actually working on the bus next time. Thanks for watching. Have a good night.